Okay. Hello, everybody. Gonna just go through, do a quick video, hopefully, on solving the tech-free problems. Yeah, so let's get to it. I'm gonna detach the screen. Hopefully, I can keep the screen like this so I can see the pictures, the questions rather, and my whiteboard at the same time. Stay there. Excellent. Okay. Let's use black today, I think. Let's go start at question 1. 1A. Might make that a little thinner. That's better. Okay. 1A. So we want to find the derivatives of all of these functions. So we're just going to differentiate these ones. So 1A, we have f of x is equal to cos 3x plus ln 5x plus 1. Okay, there we go. So we want to differentiate. So let's just think back to our derivative rules. Derivative of cos is negative sign. But always with sine and cos, be careful because you have an inner as well as an outer function. Now, in this one, the outer function would be cos of the brackets, which the derivative of that is sine. But because we have that inner function of 3x, we have to multiply through by the derivative of the inner function according to chain rule. So according to chain rule, obviously derivative of the outer times derivative of the inner, every sine and cos will essentially be a chain rule. Similar to the ln is going to be a bit of a chain rule also. So anyway, we're timesing through by that 3. So that's why I left a gap at the front, just to put that negative 3 sine 3x. Okay, ln differentiates. So ln x differentiates to 1 over whatever. So underneath the bracket stays as 5x plus 1. But once again, we've got to multiply through by the derivative of the inner, which is 5. So we're going to multiply that by 5, which ends up being 5 over 5x plus 1. Something about that strikes me a little bit odd. I'm not sure if it's just because it's been a long day or if I've forgotten something about the ln derivative. Do watch me on the ln's because those are the ones that I often make little mistakes on. So just make sure that check that against the formula sheet to make sure I'm doing the right thing. Okay, but that should be the answer, or something like it. Okay, let's have a look at f. Sorry, not f, b. We have a function of h, and that function of h is 3h cubed sine 4h plus 1. So looking at this is actually a product rule, because I have my first function u is 3h cubed times my second function v sine of 4h plus 1. 4h plus 1, yeah. Sorry, I was just trying to read my own writing. So we'll call that one v. So the f dash of h is going to be u dash v plus uv dash. So just off to the side, I'm going to figure out what u and u dash are. So u is going to be equal to 3h cubed. So before I go ahead any further, the way I know we're going to use product rule is I have a function over here with the letter that we're caring about, which in this case is h, and it's multiplied by a second function over here that also has a h in it. So whenever you see two things multiplied together in a derivative equation that both have a x or a h or a t or anything like that in it, that's when you use product rule. So anyway, back to this. The derivative, u dash, would just be 9h squared. And then v is going to be sine 4h plus 1. V dash, like before, we're just going to do the derivative of the outer times the derivative of the inner. Derivative of the outer sign differentiates to positive cos. I'm just running out of space here, so the brackets stay the same, and then we times through by the derivative of the inner, which is 4. So that becomes 4 cos of the brackets. So u dash times v is 9h squared sine 9h squared sine of 4h plus 1 plus u times v dash, so 3h cubed times 4 cos, so they'll end up being 12h cubed cos of 4h plus 1. And I believe we can stop there. Okay, see. Yeah, when I say I believe we can stop there, we obviously can. If I've asked you to differentiate, that's all I want. I haven't asked you to simplify or anything. There are things you could do to simplify that, but let's not worry about it because all I've asked is for a derivative. Okay, let's look at question C. The function of time, or I'm assuming time, t for time, is equal to 10 e, sorry guys, 10 e to the 5t plus 2. This is just a chain rule. It's a chain rule using e. So my outer function is e, my inner function is 5t plus 2. So outer function e, the derivative of e doesn't change. 10e to the 5t plus 2. This is why I don't normally use t. It looks like my pluses. 5t plus 2. Derivative of the inner function, derivative of 5t is 5. Derivative of 2 is nothing, so times 5. So that ends up being 50e 5t plus 2. You don't need to simplify that because it doesn't ask us to, so I'm not gonna. D. Last one. We have a function of q, and that x in the question was supposed to just be, I was supposed to replace q with it. I think I just messed up when I was doing that, so that's why that might be a little bit odd. So we've got 3q 5 divided by q squared minus 5q plus 1. Now, ladies and gents, this one, just looking at it, I've got my variable that I'm trying to differentiate for on top. So my variable is q. I've also got it on bottom, and looking at that, there's no easy way for me to factorize out that q or anything to get q by itself. So we can't really, unfortunately. So we can't make that a simpler problem, so we're going to have to use quotient rule. So the way quotient rule works is if you have a function of your variable, q for us, divided by another function of your variable. And the way it works, so if we have u over v, f dash of q is equal to u dash v minus uv dash over v squared. And let's just, once again, off to the side, find our u's and v's. So u dash. U is equal to 3q5. U dash will be 15q4. V is equal, why is v always so long compared to u? Anyway, q squared minus 5q plus 1. If we then differentiate that, q squared becomes 2q, minus 5q becomes minus 5, and 1 becomes 0. So we're left with 2q minus 5. Okay, we're just going to sub that into our rule here. So we've got u dash is 15q4 times v, which is that quadratic there, q squared minus 5q, plus 1, minus u times v dash, so 3q5 bracket 2q minus 5. Once again, guys, I've just been asked to find the derivative. I have zero intention of expanding out those brackets and, you know, coming up with like a simplified version. I couldn't care less about that. And on the bottom it's just v squared, so I'm just going to take that v, chuck it in a bracket and square the whole thing. Q squared minus 5q plus 1 squared. So that's the derivative. There's probably a way to make that a little bit cleaner, a little bit nicer, but like I said, it's just asked us to find the derivative, so I don't need to make it nice. Okay, question 2, on to integration. So let's look at question 2. Excuse me a second, I'll have a drink of water. Delicious. So 2a. We want to determine the exact value. This one actually says to simplify where possible, so we're going to have to simplify if it asks us to. So 2a, we've got 0 to 3, x squared on 3 plus x dx. So that's going to be equal to, let's just jump straight into the integration. Now, we've got 1/3 x squared, or x squared on 3. We're going to add 1 to the power and divide through by the new power. So that's going to become x cubed on 3 divided by 3, which ends up becoming x cubed on 9. The reason why is if I take 1/3 and divide it by 3, 1/3 of, sorry, if you take 1/3 divided into 3, each of those will be 1/9, which is where I got the 9 from. And then x would become x squared on 2. And instead of putting it in brackets, I've stolen this from one of you guys. I'm just going to write the line and then say what my upper and lower bound are, just so I can keep track of that. Obviously, I don't need a plus c because this is a definite integral. I only use plus c on indefinite integrals where there's no bounds. Okay, so let's sub in. The top one will become 3 cubed on 9 plus 9 on 2. So I just did 3 squared to get 9. That's where that came from. The second bracket, I can probably, I'll write it in. You probably don't need to because 0 cubed on 9 is 0. 0 squared on 2 is 0. So it's just going to end up being 0 cubed on 9 plus 0 squared on 2. That whole thing's going to equal 0. 3 cubed is 27, divided by 9 is 3. 9 on 2 is 4.5, which equals 7.5 units squared. The reason I've said units squared is because a bounded integral is by definition an area, and if it's an area we should put our units in it. Obviously we don't know what units it's measured in, which is why we say units squared. Okay, B, we've got the integral from 2 to 1, or from 1 to 2, of 3 over 4x plus 5. Okay, I hate these ones because this is those ln ones, and like I said, this is my weak point, so these are ones that I really have to stop and think about. So, the way you sort of do these is you consider a similar function and sort of differentiate it. So you sort of go backwards. So let's think about our, we're going to end up with ln 4x plus 5 essentially, to get that. So let's just write that. If I was finding the derivative, this will sort of make sense in a second. If I was finding the derivative of ln 4x plus 5, notice that 3 is not anywhere, and we're going to talk about that in a second. If I differentiated that, well, the derivative of ln 4x plus 5 is just going to be 1 over 4x plus 5. And then we times by the derivative of that inner, which would be 4, which gives us 4 over 4x plus 5. So that's almost that one there. So what I've got to consider is how come I have 3 on top instead of 4 on top? What could I, where is that 3 coming from? And what I could essentially do is times it, because I want to have that 3 on top, right? So times it by 3, and that would put a 3 on top of the fraction. But I also shouldn't have a 4 on top of the fraction. So I'm just going to divide by 4. Because then that one, sorry, I should highlight this. This is no longer part of the answer. Because that would then give me, once you cancel all that, you'd end up with 3 on 4x plus 5. Essentially what that means, ladies and gents, this bit here, that is what the derivative of ln x is. ln 4x plus 5. That's a derivative of ln 4x plus 5. But that's not quite what our integral looks like. So to make it look like our integral, we'd need to times the derivative of that by 3/4. And we can then work in reverse and say, okay, I'll just do this in red. Times 3/4. If I times that derivative ln 4x plus 5 by 3/4, that gives me that when I fully differentiate it. So to then get the integral of that, it's just going to be that there. So it's going to be, I'm hoping that makes sense, guys. If not, let me know. 4x plus 5. There is also just a rule that you can use. I'm just trying to explain why the rule gets that. So basically the rule would be you integrate that, which gives you ln 4x plus 5. That 3 would still be in the front of it, and you divide by the derivative of the inner. So that might actually be an easy way to think about it. And then you just do, it was 2 to 1, wasn't it? 2 to 1. So what we end up getting is 3/4 ln 4 times 2 is 8, plus 5 is 13, minus subbing in 1, 4x is 4 times plus 5 is 9, 3/4 ln of 9, and we can simplify that using our log laws. We've got to put the 3/4 as a power above the numbers in front. Sorry, there's a hair on my screen. So that would end up equaling ln of 13 to the power of 3/4 minus ln 9 to 3/4. And then we can combine them using our log laws, which is ln 13 to the power of 3/4 over 9 to the power of 3/4. Of course, 3/4 being the 4th root of that cubed. But obviously, tech free, I don't need you to do that. Okay, on to C. That was a bit of an odyssey B. Let's go on to C. From 0 to pi. 0 to pi of 3 sine 2x dx. 2x dx. Okay. So if we just go back to our formulas, the integral of sine is negative cos. So on the next line, straight away, it's going to be a negative cos. Note, I am leaving some space out the front because there is going to be a coefficient. That number that was in front up here always just stays behind. And then we divide by the derivative of the inner. Remember with chain rule, for derivatives, we times by the derivative of the inner, but integration is undoing that. So for integration, we've got to divide by the derivative of the inner. So we're going to divide by that derivative of the inner to 2x. And I'm going from 0 to pi. So that becomes negative 3/2 cos, oh, sorry, I forgot my bracket there, 2 pi minus negative, so minusing away the lower bound will become plus 3/2 cos of 0. Now we just need to use our angle rules essentially here. I'm not gonna lie, guys, I have zero memory of ever doing these before. I know I made an answer sheet for this, but it must have been a huge week for me because I remember none of it. I have zero memory of doing this question. But that's more me sliding into dementia, apparently. Still, I'm very confident that we're doing the right thing here, so there you go. Okay, cos, if you look at your unit circle, cos measures the x-coordinate, so how far along you are. So at an angle of 0, cos is actually 1. It's actually at 1 over here. It's as big as it can be. So cos of 0 becomes 1, so 3/2 times 1 is 3/2. Cos of 2 pi is just a full revolution, 2 pi. So cos back here is, once again, 1. Did I say it was 0 before? I meant 1. I think I said 0 before. Cos of 0 is 1. Cos of 2 pi is once again 1. So we then have negative 3 halves plus 3 halves, 0 units squared. Obviously it's doing that because we have area above and below the x-axis. We don't need to really worry about that though. But our answer there would be 0. And that was C, so time for D. D for enterprise. That is a joke that none of you would get. That's alright. I'm clearly slowly losing my sanity. Dx. Okay, so we have the integral from 1 to 2 of 10 times e to the 10x. Okay, so once again, guys, if you're ever stuck on integration, just jump back to the derivatives and think what you'd have to do. If I was differentiating something that looked like this, it's basically a chain rule problem. I'd find the derivative of the outer, and then I'd times by the derivative of the inner. Now, because we're doing integration, we've got to do the opposite. So we're going to find the integral of the outer, and then divide through by the derivative of the inner, instead of timesing by that derivative of the inner. So this one's going to equal, now e to the x, when you integrate, stays the same. So it's just going to become 10e to the 10x. But we're just going to divide by the derivative of the inner. The inner here would be that little upper bit of the fraction, which is 10x. So we divide by 10, because the derivative of 10x is 10. And we're integrating that from 1 to 2. Now, the 10's cancel. We get e to the 10x from 2 to upper bound 2, lower bound 1, which then becomes e to the 20 minus e to the 10. Now, I did a silly last time in the last solutions, and I combined them. You actually can't combine them because they're not times or divided by each other. So that's just your final answer, e20 minus e10, so some number. And I might just chuck a unit squared on there. So why not? Okay, and that was D. Oh, sweet, we're all the way up to question 3. Look at us go. Is this a... Oh, no, I think... Oh, no, it's only one page. Thank goodness. I was about to stress out. I do want to get home tonight. Okay, so we're up to question 3. The good news is, those questions, there was a lot of finicky stuff in them, but the good news is the rest of them aren't actually too bad. Actually, I think question 8's a bit of a muck around, but it is what it is. Okay, question 3. A function is found to have a rate of change given by 8t plus 5, where t is time in seconds. Okay, straight away, those words, rate of change, they jump... Stop highlighting stuff. Stop it. Be good. Straight away, rate of change. A function has a rate of change. That means that's the derivative. The derivative is 8t plus 5. So straight away, I'm going to say y dash, so the derivative is 8t plus 5. I've got to stop using t's in my questions. They just look too much like my pluses. Let's try and do it like the word does. That actually looks better. 8t plus 5. Where t is time in seconds. Determine the original function given that it is equal to 24 at 2 seconds. So in other words, x equals 2, y equals 24 is what that means. So we have a known point 2, 24. So all I've got to do is determine y, the equation for y. So I don't want the rate of change equation, y dash, I just want y. So y equals, we just want to undo that rate of change equation, so it's been differentiated, that's what the dash means. So we're just going to differentiate 8t plus 5. Sorry, I'm doing my t's with a tail. And we're differentiating that with respect to t. Integrating that with respect to t. Okay, the integral of 8t is 8. So, I'm so out of the habit of drawing t's like that, it's going to take me a little while. 8t squared on 2 plus 5t plus c. That ends up being 4t squared plus 5t plus c. Now, we have that known point, x equals 2, y equals 24, so I'm going to sub in 224. 2, 24. I think t... No, that's a different question, never mind. So I end up getting 24 equals 4 times 2 squared plus 5 times 2 plus c. 24 equals 4 times 2 squared. 4 times 4 is 16. Plus 5 times 2 is 10. Plus c. 16 plus 10 is 26. Minus 26 from both sides. C equals negative 2. So therefore your function y is just equal to 4t squared plus 5t, sorry I've forgotten about my tails, minus 2. There we go. Question 3 done. Not as soon as you understand what that language means, these ones are just like easy as. As soon as you see gradient function, as soon as you see rate of change, things like that, if it says the gradient function is this, that's the derivative. The rate of change is this, that's the derivative. If it says find the rate of change or find the gradient function, obviously the opposite, you have to derive it to find that value. Okay, question 4. The velocity of a particle is given by Vt equals 3 sine 2t minus pi, where t is measured in seconds. Determine the acceleration of the particle when t equals pi. So we have velocity of t equals 3 sine 2t minus pi. You notice, guys, all I do, like, I'm very much saying out loud my thought process as I'm doing these, and for me, always the first thing I do is write down the equation. Because while I'm writing it down, I'm thinking about, okay, what information am I being given? I've been given the velocity. What am I needing to find? I'm needing to find the acceleration. Okay, what connections do I know between acceleration and velocity? Okay, I know that acceleration is the rate the velocity changes at, so I'm just going to differentiate to find it. So I'm just going to say that the acceleration over time is just going to be equal to the velocity integrated over time, which is going to be, let's integrate this. So differentiate. I need to differentiate this. Chain rule problem. Outer function 3 sine, inner function 2t minus pi. Oh, you'd think for a guy that's made a bunch of t problems, I could draw one that doesn't look like a plus. Anyway, and we're going to eventually find the acceleration at time equals pi. Okay, that's for later. Let's differentiate. So as always, the 3 is going to hang out. Sine differentiates to positive cos. The brackets will never change. Minus pi. But because it's a chain rule, we've got to times by the derivative of that inner, which would be times 2. Which gives us 6 cos 2t. Oh my goodness. You guys are probably laughing at me at home. Don't laugh at me, that's mean. And determine acceleration when the particle... We have our rule for acceleration now, so all we need to do is say, well, the acceleration when time is equal to pi is equal to 6 cos 2 pi minus pi. So I've just replaced t with pi, which becomes 2 pi minus pi is just regular pi. 6 cos negative... sorry, that's just regular pi. If we look at our unit circle... Cos, once again, finds our length. 0, it's at 1. 90 degrees, or pi on 2 radians, it's at 0. Because there's no length, because it's just a vertical line. And if we go to pi, it's in the negative quadrant. But it's at its full length, so that would be negative 1. So cos pi equals negative 1. Equals 6 times negative 1 equals negative 6. It hasn't told us what this is measured in, but just out of habit, I probably should, because it's a question about acceleration, units, and it's told us time is in seconds, so seconds squared is how you do acceleration. So velocity is units per second, acceleration is units per second squared. Okay, question 5. Solve each of the following equations. Oh, joy. Y equals log 10 1,000. 1,000. So for this one, look, I'll be honest, guys, I can look at that and see the answer's 3. You guys probably can't, and that's probably just because I'm more used to log form than you are. So log form, remember, is just a way of rewriting an exponential function, something with an index. So let's rewrite this to be an index form. So in index form, the base of the log is the base of the thing with the index. Computer's frozen. That's not ideal. No, not entirely. Okay. We're back. I'm not sure what's happening here. It's not letting me write. Let me just I'll reconnect to the base station of my laptop just so maybe the battery's a bit low or something. Freak out too much. But I'm going to try and flip it around. Okay, it doesn't want to flip around. Okay, that's alright. Okay, that's interesting. Oh, no, we're back. We're back in action. So, the base of my thing that has an exponent is going to be 10. Because that's the base of the log. The index, or the exponent, is going to be whatever is the subject of the formula, y, equals, and then equals is going to be the subject of the log, 1,000. So 10 to some power equals 1,000. 10 times 10 is 100, times 10 again is 1,000. So that's what let me say y equals 3. And that's all you need to say for that one. Okay. The question 2 is very similar. I did mess up a little bit here, guys, and I do apologize. These ones should really be in brackets, and I didn't do that very well. No, didn't make that as clear as I should have. Oh my goodness. My pen's jumping in and out. I think maybe it's low battery, perhaps, or the... Let me just take it apart for a second. It shouldn't actually be low battery, because I only replaced it not long ago. Let me just... I've got it the right way around. Okay, it's flashing at me again, so it should be good. Okay, let's do B. Yeah, so sorry, as I was saying, I should have had those in brackets, just make it really clear that 4x plus 7 is the subject of the log. So for B, we have 3 equals log 3, 4x plus 7. So all we've got to do there, once again, rearrange it into out of log form. Sorry, so that would be 3 to the power of 3 equals 4x plus 7. 3 to the power of 3 is 27 equals 4x plus 7. Minus 7 is 20 equals 4x. X equals, divide both sides by 4. X equals 5. Okay. Question C. This one's nasty. I may not fully solve this one, guys. Just I'll show you up to where it's mostly simplified. We probably won't find X, though, just in the interest of time. I did steal this one from your textbook, so blame your textbook for having a dodgy question, not me. Even though I'm the one that copied it, but whatever. So, on the left-hand side, we have log 10, oh my goodness, of 3x plus 2. 3x plus 2 plus 6 log 10 of 2. And that is equal to 2 plus log 10 of 2x plus 1. Goodness, I tell you what, I think on the way home I'm going to stop and get a mad feed because I am hungry as. Doing maths when you're really hungry is difficult. Okay, Left-hand side, guys, let's clean it up. Straight away, a number in front of a log becomes the power. So that's going to become log 10, 2 to the power of 6. Also, if you have a log of the same base added together, so log 10 plus log 10, you multiply what's inside. So on the left-hand side, it's going to become log 10 bracket and 3x plus 2 times, and I said that 6 is going to go up there, 2 to the 6. So it's going to be 2 to the 6 times bracket 3x plus 2. Close bracket. On the left-hand side, it's a bit trickier. Can you see this 2 here? You know how up in question 1, I said, okay, well, log 10 of 1,000 has to be equal to 3. So log 10 of what would be equal to 2? So log 10 to the power of what equals... Sorry. 10 to the second power equals, well, 100. So log... I'm going to write it up here. I know it's not part of that working out, but log 10 of 100 equals 2. And what I can do is I can replace that 2 with log 10 of 100. And that's kind of counterintuitive. Normally, with numbers, we want to get away from complicated things like logs, but in this case, it's actually going to help us to simplify. So I'm replacing that 2 with log 10 of 100, and that's times by log 10 of 2x plus 1. And once again, I have the logs together, and I can just times them. So I end up getting log 10 of 2 to the 6 times 3x plus 2 to the 7. So just times that 2 to the 6 into the brackets. So 2 to the 6 times 2 is 2 to the 7, and I'm just times it by the 3x, equals log 10 100 bracket 2x plus 1. Should be 200x plus 100. And then because I have both sides of my equation now are just log 10 of something, so I'm saying that log 10 of that bracket is equal to log 10 of that bracket, which means that those two brackets have to be equal to one another. So I can say that 2 to the 6 times 3x plus 2 to the 7 is equal to, let's do it, 200x plus 100. Now, like I said, once we got up to this stage, technically we should be solving for x. I will not be giving you a log question this difficult in your tech free. This is really something that you'd probably, if I gave this to you normally, I'd expect you to just chuck it in your solver and get your solver to solve it for you. So I'm going to stop there. You can keep playing around with that to get x by itself. So 2 to the 6, 2, 4, 8, 16. You can't see, but I'm counting on my fingers. 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 would be 64. So 64 times 3x plus, do I want to solve it? No, I don't. Okay, sorry. But yeah, that is solvable tech-free. It's just going to take a while. I'm not going to need you to do anything like that, so I'm just not even going to bother. Like I said, I did steal this one from your textbook. Question D. Okay, this one's sneaky-deaky. E to the 2a minus 2e to the a equals 35. Okay, looking at that, my first gut reaction is that is too complicated. I don't want to solve it. And that's actually a good response to have, because that is too complicated to solve, and we can't solve it the way it is. It doesn't mean we get to stop, it just means we need to make the equation easier. Now, when I look at that, what's making that equation difficult is the e to the a. The e to the a over here, that one, just the 2 itself isn't an issue, and then the e to the a here. So what I'm going to do is I'm just going to say set e to the a equal to x. So I'm just going to choose a variable and replace e to the a with it. So when I do that, what I get is instead of e to the 2a, it becomes x squared, so that 2 sort of just hovers up there. There's an index law reason why, but I'm just not going to go into it now. But suffice to say, e to the 2a, if e to the a is x, becomes x squared. Over here it becomes minus 2x equals 35. Oh my goodness, that's a quadratic. You learnt in Unit 1 how to solve quadratics, and you learnt it in Year 9 as well. So let's solve this. To solve a quadratic, you need to have it equal to 0, so I'm just going to minus 35 from both sides. So I end up with x squared minus 2x minus 35 equals 0. Now looking at that, that's a monic quadratic. Monic quadratics are really easy to solve using factorizing sometimes. So let's check if I can factorize that into two sets of brackets. The way this works is it will be x plus a, x plus b, where, this is important, where a plus b equals the end number, negative 35, and a times b equals the middle number, negative 2. There are infinite ways to add two numbers to negative 2, but there's very few ways to multiply numbers to be negative 35. So I'm just going to check the factors of 35. 1 and 35, there's no way to add them to get negative 2. 2 doesn't, 3 doesn't, 4 doesn't, 5 does. 5 times 7. Okay, I want them to add to negative 2, so if I make that 7 negative, negative 7 times 5 is negative 35. Negative 7 plus 5 is negative 2. So my factors are negative 7, positive 5. X minus 7, x plus 5 equals 0. Okay, now, next step. For the left-hand side to equal the right-hand side, either the first bracket can equal 0 or the second bracket can equal 0. So this is just one of the properties of quadratics. It's one of the ways we solve for what values x can take on. So to make the first bracket equal to 0, x can equal 7. To make the second bracket equal, it can equal negative 5. So I can say, I now know what x is equal to, so I can replace x with e to the a again. So I can say, therefore, e to the a equals either 7 or negative 5. I can, however, ignore the negative. The reason why is because e is a positive number. There is no way in this universe to take a power, take a positive number and raise it to a power, positive, negative, anything, no matter what the power is, the answer of that positive number to a power can never be 0 or less. It can't be a negative and it can't be 0. We call those imaginary numbers. They don't exist. So that's why I can say e to the a does not equal a negative. It can't. So I can cross out that option, which leaves me with e to the a equals 7. But I still haven't solved for our unknown a. So e is just a number. It's like 2.71 or something. But a is my unknown. So I just need to make a the subject of the formula. So all I'm going to do is rearrange into log form. A equals ln 7. So I don't need to simplify any further than that. Make sure you do go to the step, though, of getting a by itself, because there will be a mark for that final statement of fact. Alright guys, 3 questions left. That last one was like a bunch of questions in one. So, and I've just realized that Q is, question 6 is difficult. We're starting to get into the CF here, guys, and they are tricky. Tricky. So let's look at question 6. We have some integral. Now, I believe... Oh, no. That's equal to 20. Wasn't there some problem that I gave you guys that should have been equal to 56? Maybe that was a different sheet. Maybe that was a homework sheet. I think that was a homework sheet. Yeah, I've done it correctly here. So the integral from 1 to some number q, we don't know what q is, of 6 plus 2p dp equals 20. So the area of this function, the area underneath this function from 1 to q is 20 units squared, is all this means. And it's basically just saying find q. So all we've got to do is figure out what value q is. So to do that, we're going to integrate, sub in our bounds, and then solve. So it's just an algebra problem. Honestly, there's a twist of integration, but this is mostly just an algebra problem. We have a variable, but we know what this is going to be equal to. So let's integrate 6 integrated will become, and now our variable is p. I know we normally use x, but we can use any letter. Our variable is p, so 6 will become 6p. 2p will become 2p squared on p, which will just become p squared. And that's integrated from 1 to q equals 20. So let's do our upper minus our lower. 6q, because I'm replacing my variable with q, plus q squared minus 6 times 1 plus 1 squared equals 20. 6 times 1 is 1 plus 1 is 7. So we get 6q plus q squared minus 7 equals 20. Guys, we're going to solve it like a quadratic. So I'm just going to shuffle that q to the front. Q squared plus 6q and minus 20 from both sides, which gives us minus 27 equals 0. Much like that previous question, actually, we're just going to do q plus something equals 0. Okay, long day. What numbers multiply to negative 27? Add to 6. 27, you got 1 and 27. No way to make them. Add to negative 6. 2 doesn't go into it. 3 does 9 times. Okay, 3 and 9 are 6 apart. So if we make positive 9, negative 3, they add to positive 6. So that should be a q minus 3 down here. Q plus 9, q minus 3 equals 0. So therefore, q can equal positive 3 or negative 9. Now, I think I talked through this with some kids in class, and what I would say is 3 is our most likely answer, but 9 is also a possible answer. Oh, sorry, no, it's not. No. I take it back. Sorry, I'm thinking about the homework question. 9 is not possible. Negative 9 is not possible. And the reason why is q is our upper bound. Our upper bound up here. Our lower bound is 1. So we can't have an upper bound being below the lower bound. So because 9 is below the lower bound, that can't be our upper bound. So q equals 3. So have we answered the question, determine a value of q such that, yep, we have done that. Cool. So that's all that question, q equals 3. So if you integrate that function between 1 and 3, the area is 20 units squared. Cool. Sweet, 2 questions to go. We're just smashing it, guys. So a particle has displacement given by displacement over time equals 3t4 minus 10t3 plus t squared minus 15. Determine the acceleration at time equals 2. The trick here, to go from displacement to acceleration, you've got to first go to velocity by differentiating. Then you differentiate that to get to acceleration. So I'm just going to say, I'll write out my rule. Displacement to do with time equals 3t4. 3t4 minus 10t3 plus t squared. Oh my god, but these t's and these pluses, I tell you what. You guys should ask for a new teacher. Okay, so that's my displacement. My velocity compared to time is just the derivative of my displacement compared to time. And the derivative of that line above is just going to be, well, the power drops down, 12t3 minus 30t squared plus 2t, and then that 15 disappears. Then my acceleration compared to time is just equal to the velocity differentiated. So that'll be 36t squared minus 60t plus 2. And what I want to do is find the acceleration after 2 seconds. So the acceleration at time 2 is equal to 36 times 2 squared minus 60 times... Keep going to write 2. I mean to write t plus t. Okay, 36 times 4. I don't know that off the top of my head, but 36 times 2 is 72. And times that by 2 would be 144. 60 times 2 is 120, and plus 2. So 144 minus 120 is 24, plus 2 is 26. Now, once again, I haven't given you what the displacement is measured in, so I'm just going to say units per, but I have told you that time is in seconds per second squared. Right, question 8. Lucky last revision question. We have question 8. And I'm going pretty good for time too. A function below has the equation fx equals minus 2x squared plus ax minus 5. Determine the integral from 1 to 3. So it's really saying find this area here. So what the question's really asking me is find that area. The problem, I don't know what A is. A is the problem. The solution, I've been given a known point. If I have a known point, I can figure out an unknown value, luckily. So let's just find that A value. So f of x equals negative 2x squared plus ax minus 5. And I know that function passes through the point 3, 1. Sub in 3, 1. So 1 equals negative 2 times... Sorry, there's just people coming and going past the thing, and I have no clue why. 3 squared plus a times 3 minus 5. So 1 equals... 3 squared is 9, negative 2 times 9 is negative 18, plus 3a minus 5. Negative 18 minus 5 is negative 23, so I'm going to add 23 to both sides. So 24 equals 3a, a equals 8. So I just divided by 8 there. Sorry, I should have used red for that other one as well. Okay, so a equals 8. So then I can then say that f of x equals negative 2x squared plus 8x minus 5. And then all I need to do is find the area. So from 1 to 3. 1 to 3 of negative 2x squared plus 8x minus 5 dx equals, so integral of negative 2x squared would be negative 2x cubed on 3 plus 8x squared on 2. You know what, I'm just going to skip to my 4x squared. No need to make this more complicated than it needs to be. 5x. No plus c because there's bounds, and our bounds are 1 to 3. Okay. Equals negative 2, and we're subbing in 3 cubed on 3. I'm actually going to do these one by one as I go, just because I find that a bit easier. 3 cubed divided by 3, one of those 3's essentially cancels. So it ends up being negative 2 times 9, which is negative 18. 4x squared integrated, subbed in 3, plus 4 times 3 squared. 3 squared is 9 times 4 is 36. Plus 36. Minus 5 times 3 is... minus 3 is 15. Minus 15. And now we're minusing away the lower bound. So I'm not going to solve this all at once. I'm going to put it in brackets. The reason why is because that negative is applying to all 3 of the terms. And if you forget about the negative, you will make a mistake. You get the answer wrong, and then you'll fail the exam. Your parents won't love you, and they'll kick you out on the street. And you don't want that. So remember to put your lower bound in brackets so you don't mess up. Probably shouldn't tell you that your parents won't love you if you do this. I'm sure your parents will still love you if you forget your lower bound to minus, but, you know, don't want to risk it still, so put it in. So that becomes negative 2, 1 cubed is 1, so it just becomes negative 2 on 3, 4 plus 4 minus 5. Okay, so we've got negative 2/3, plus 4 minus 5 is negative 1, so we end up having negative 1, so negative 2/3 minus 1 would be negative 5/3. But we're minusing that negative 5/3 away, so we're actually plus 5 on 3. Okay. Negative 18 plus 36 would give us 18. I'm having a mind blank. 36 take 18. Take 10 would be 26. Take another 8 would be 18. Yes, we get 18. Minus 15 is 3. So we end up with 3 plus 5/3. 3 in thirds is 9. 9 plus 5 is 14. 14 over 3 units squared. Bish bash bosh, we're done. And look, my parents must love me, because I think I got that right. Okay, I hope that's... Whoa, that's new? I'm not touching that, guys. It's doing that itself. Okay, that's mini. It's trying to chase my thing away. Oh, right, there we go. It's up, but it's upside down. Stop recording. Oh no, my whole thing's upside down. Maybe I'm upside down. Okay, hope that helps, guys. Good luck. See you all on Monday.